in this last video for limits at infinity, we're going to look at trig functions. And you see trig? Yeah, we're going to do trig. Okay. To be honest, the trig functions we're going to look at are sine and cosine. You shouldn't ever be asked to find limits as x goes to infinity of tangent, cotangent, cosecant, and secant because they are funky. They have asymptotes all the time that are breaking up the party. However, sine and cosine go on and on and on forever, right? Okay. So what's happening when we ask about infinite limits is I'm going to walk on this graph forever. What y value do I level off at or do I blow up? And here we're kind of doing neither, right? I'm not blowing up to infinity or negative infinity. I'm not leveling off to one number. I'm bouncing forever between 1 and negative 1. Okay. Now, even though that's very specific of giving me a range of values that I'm always bouncing around, because I bounce forever, these two limits, as I just look at them, are going to be does not exist. Because to exist, for limits at infinity, it's got to level off to one number or blow up to a giant number. It can't bounce forever. Okay, now, here's the thing though. Students see this and they go, got it. I'm going to memorize this fact. Does not exist. Done. Okay, well, here's the tricky part. What if they ask us to do something that looks like this? Students will say, does not exist because there's a cosine, and you're actually going to get it wrong. Okay, the reason why that would be wrong to write does not exist is because what's happening as x goes to infinity is that the top is going to be always bouncing between negative 1 and 1. But the bottom is a gigantic number. So what's negative 1 divided by a huge number? 0. What's 1 divided by a huge number? 0. So this bottom here is dominating, and even though the top is always bouncing, it's always bouncing between a finite value between negative 1 and 1. The bottom's gigantic. This is actually going to have the answer of 0. Okay, so if it's just a sine and a cosine, it does not exist. But if it's paired with other things, you really have to use the ideas of which thing is growing bigger or smaller, all that kind of idea to try and figure out what the limit is overall. All right, good luck.